Most people still don't realize how ambitious this project truly is, but Israel is quietly reshaping an entire desert region with a move that sounded unthinkable not too long ago. A man-made river carved into dry land, flowing through one of the harshest environments in the Middle East. And into this new waterway, scientists released 1 million fish. Not a handful for a basic test. Not a symbolic gesture for publicity. A full million, deliberately introduced into a place that hadn't seen a living river ecosystem in decades. What has followed since then has captured the attention of researchers around the world. If you enjoy stories where engineering and nature collide in unexpected ways, stay with me, because this one builds layer by layer. To understand how bold this project is, you first need to picture the Negev Desert as it truly is. This is a landscape that barely receives 100 millimeters of rain per year in some areas. For most countries, that amount puts a place well into the category of near-permanent drought. The land is tough, unforgiving, and slow to recover from even the slightest disturbance. Yet Israel has always treated this region as something more than a natural barrier. For decades, the Negev has been the testing ground for new technologies, agricultural methods, and water management systems designed to push the limits of what's possible in dry climates. Israel already has one of the most advanced water systems on Earth. Nearly 90% of its drinking water comes from desalination plants along the Mediterranean coast. That percentage is unmatched by almost every other nation. But producing water for homes, agriculture, and industry doesn't automatically restore damaged ecosystems. Freshwater for people is one thing. Freshwater for nature is a different challenge entirely. That is why Israeli engineers, environmental experts, and researchers from Ben-Gurion University began exploring an idea that felt risky at first. What if they could revive dry riverbeds using purified, highly treated wastewater? This water isn't raw sewage. It isn't something dumped into the environment without oversight. The purification process removes solids, pathogens, nitrogen compounds, and chemical contaminants, bringing the water to a level that meets strict ecological standards. The approach is called ecological flow restoration, and it has been used in places like California and Spain. But Israel is pushing it further by applying this method inside true desert conditions. Before building the new river, the country tested similar ideas in places like the Be'er Sheva River Park. That river was once heavily polluted, but long-term cleanup efforts and steady ecological water flows transformed it into a vibrant public space with wetlands, wildlife, and recreational areas. That success became a reference point. If it worked in a semi-arid region with urban pressures, then perhaps it could succeed even deeper into the desert. By 2024, Israel launched its most ambitious restoration project yet. Engineers designed a flowing river channel supported entirely by purified water routed from advanced treatment plants through underground pipelines. Environmental authorities monitor the water continuously, checking oxygen levels, nutrient concentrations, microbial balance, and salinity to ensure the water remains healthy enough to sustain life. What began as a controlled engineering experiment slowly started to resemble the early stages of a real river system. Once the water was moving, the next step felt almost inevitable. A river becomes more than a river only when something lives in it. A water channel without life is functional, but it doesn't behave like a true ecosystem. This is why scientists made the bold decision to release roughly 1 million fish into the restored desert river. The species were carefully chosen after months of testing. Tilapia were one of the primary choices because they are resilient and capable of surviving sudden temperature changes. Carp and small native desert species were also included, providing a mix of fish that could fill different ecological roles. Introducing such a large number of fish wasn't reckless. It was a calculated strategy grounded in ecological principles. Fish accelerate ecosystem recovery. Their presence affects nutrient cycling, algal growth, sediment movement, and the availability of food for birds and insects. Israel has seen this effect before. The Kishon River near Haifa, once infamous for its industrial pollution, now supports turtles, fish, birds, and a growing network of recreational routes after years of careful restoration. Fish were an essential part of that transformation. But the Negev is far more extreme than the northern coastal plains. Desert temperatures can rise above 40 degrees Celsius during the day and drop sharply at night. Shallow water warms quickly, evaporation increases, and dissolved oxygen can fluctuate. Every one of these factors can threaten fish survival. That is why researchers approach this operation with a level of caution rarely seen in ecological projects. They spent months testing water quality, adjusting flow rates, shading certain areas, and planting early vegetation along the riverbanks. Only after confirming that the environment was stable did they approve the mass release. The day of the release felt like a quiet milestone, even though the public barely heard about it. Trucks carrying large oxygenated tanks moved slowly into the desert valley. Specialists stood ready with measuring equipment to check oxygen and temperature differences as soon as the tanks were opened. When the first wave of fish entered the river, the scene struck many observers as surreal. Imagining fish in a desert is one thing. Watching them swim into a river where sand dominated for generations is something else entirely. The first few weeks were the most critical. Newly introduced fish often experience high stress, and it's common for survival rates to drop dramatically during the initial adjustment period. But the early results stunned researchers. Surveys conducted by the Nature and Parks Authority in late 2024 showed survival rates surpassing 75%, far higher than expected. Follow-up checks in early 2025 confirmed the trend. The fish were not only surviving but exploring different sections of the river, settling into slow-moving areas, and forming early shoals. The real surprise came a few months later. By March 2025, researchers found evidence of active reproduction. Tilapia fry were discovered near shallow, plant-sheltered zones where the water warmed earlier in the day. This discovery instantly changed the scientific conversation. A river stocked with fish is impressive. A river where fish begin reproducing naturally is another level. It means the ecosystem isn't simply functional, it's stabilizing. It's building the foundations needed to sustain itself with less intervention. Achieving this in a desert environment is rare. Many restoration projects in arid regions struggle for years before seeing signs of natural reproduction. As the fish settled in, the riverbanks began to change in subtle but measurable ways. Birds were among the first responders. Herons, kingfishers, and other species that depend on fish sightings began returning to the area. Locals who hadn't seen these birds in years started spotting them perched along the flowing channel. Photos were sent to environmental agencies documenting the changes. Once birds arrive, ecosystems begin accelerating. They carry seeds, distribute nutrients, and signal to other wildlife that water is present and stable. Vegetation followed. Native reeds and salt-tolerant plants began anchoring themselves near the water's edge, and some grasses started appearing in places that remained moist for several weeks at a time. Satellite images from the Israeli-French observation system revealed a clear increase in vegetation density along the river's path. A faint but undeniable green line began cutting across the sandy terrain. Anyone looking at those satellite images without context would assume it was a natural watercourse, not a brand new creation fed by purification pipelines. But every positive development brings new concerns. Overpopulation is one of the biggest risks in young ecosystems. If fish multiply too quickly, oxygen levels can drop, especially during heat waves. To prevent this, Israel installed automatic monitoring stations along the river. These devices track dissolved oxygen, temperature, nutrient loads, and flow rates around the clock, sending real-time data back to Ben Gurion University laboratories. Environmental teams review the data daily, ready to intervene if something shifts unexpectedly. This monitoring network is now one of the most advanced ecological observation systems in any desert restoration project worldwide. The social impact of the river has been just as significant. Communities living near the Negev's development areas have started seeing more researchers, hikers, and school groups. Students now visit the river to learn about water engineering, ecology, and climate resilience. Families walk along the flow during cooler evenings, enjoying an experience that was impossible 20 years ago. Even psychologically, the presence of running water changes the way people relate to their surroundings. It introduces a sense of renewal and possibility in a place long associated with dryness. This project isn't just about beauty or recreation. It's about climate adaptation. The Middle East faces rising temperatures, decreasing natural rainfall, and increasing evaporation. Restored ecosystems act as buffers. Plants cool the surrounding land, reduce soil erosion, and help stabilize dust levels. Birds and insects support pollination for nearby agricultural projects. These benefits compound over time, turning a single river into a regional resilience tool. As the river continued to evolve, researchers began asking a question that had once felt too ambitious to even consider. Could this restored ecosystem become permanent? A river in the desert is not just an engineering achievement. It's a living system with needs, risks, and long-term commitments. The answer depends on one key factor: consistent ecological flow. As long as Israel maintains its network of treatment plants and continues sending purified water into the channel, the river can survive indefinitely. This isn't a seasonal wadi dependent on rare storms. This is a managed waterway with a controlled supply designed to mimic natural flow patterns. The early success of the project has already influenced government discussions about expanding similar restoration efforts. Several dry basins in the Negev have been identified as potential candidates for ecological revival. Each one presents its own challenges, from soil composition to surrounding land use, but the core principle remains the same: water gives life. And with the right infrastructure, even extreme environments can sustain thriving ecosystems. Plans for expansion include installing additional monitoring systems and designing wider green corridors where vegetation can spread more easily. If these basins are restored, the ecological map of southern Israel could look entirely different by the early 2030s. International interest in the project has been steadily growing as well. Delegations from Morocco, Jordan, the United Arab Emirates, and several regions of Saudi Arabia have already visited to study the restored river. Even water managers from parts of California and Arizona, who face their own climate pressures, have shown interest in the system's design. The reproduction of the fish earlier than expected was a key turning point. It demonstrated that the project isn't just symbolic. It is scientifically meaningful. A full ecological cycle has begun in a place where life seemed nearly impossible not long ago. Reports documenting the early results are already being compiled. Israel intends to share its methods, data, and monitoring techniques with researchers around the world. The idea isn't just to show what happened in the Negev. It's to offer a potential blueprint for other countries dealing with drought, water stress, and environmental degradation. While every region has its own challenges, the principles behind ecological flow restoration can often be adapted. Purified water, controlled flow, native species restoration, and continuous monitoring form a flexible model that can be adjusted across different climates. While all these scientific and political conversations were unfolding, the living river itself continued to grow more complex. Aquatic insects began appearing in higher numbers. Their presence is important because they form the base of the food web. Water beetles, larvae, and small crustaceans were found in areas where the flow rate slowed down just enough to allow them to thrive. Their arrival improved the river's biological balance. Algae, which can bloom aggressively in young ecosystems, began stabilizing due to natural grazing patterns. Bird activity intensified as well. Researchers documented new nesting behavior along the riverbanks. Some species that were rarely seen in the Negev now appear weekly as the river provides a reliable food source. Migratory birds also benefit. The Middle East sits along one of the most important bird migration routes in the world, known as the Great Rift Valley Flyway. Around 500 million birds travel this route each year. A stable river ecosystem in the Negev offers them rest, food, and water during long flights. This adds another layer of value to the project beyond national borders. As vegetation thickened along the banks, the river started to influence temperature regulation in its immediate surroundings. Shade from growing reeds and trees reduced evaporation in certain zones, allowing moisture to remain trapped in the soil for longer periods. In dry climates, even small amounts of moisture can lead to significant ecological shifts. Seeds carried by wind or birds can take root more easily. ground stability improves, reducing erosion during rare rain events. These conditions slowly create a microclimate, a small zone where temperatures, humidity, and soil quality differ from the surrounding desert. Local farmers began noticing subtle benefits too. While the river was not designed as an agricultural water source, nearby fields experienced fewer dust storms. When the land retains even a small amount of moisture, dust particles are less likely to rise. This helps protect crops from wind damage and improves air quality for nearby communities. Over time, stabilized land can even reduce maintenance costs for roads and infrastructure. These indirect gains often go unnoticed at first, but they accumulate into meaningful improvements in quality of life. None of this happened by accident. The river's behavior is influenced by careful infrastructure planning. Underground pipelines regulate flow rates, keeping the river from drying out during heat waves or overwhelming certain areas during maintenance cycles. Automated sensors detect any shifts in water quality, such as rising ammonia or decreasing oxygen. When something looks off, alerts go straight to technicians and researchers who can intervene before the ecosystem suffers damage. This combination of engineering and constant surveillance is what makes it possible to sustain a living river in such a demanding environment. Looking ahead, the next major step in the project involves expanding biodiversity. Scientists are preparing to introduce amphibian species that can handle desert conditions. These amphibians could help control insect populations and provide another indication of ecosystem health. Their presence will further test the river's stability because amphibians are sensitive to pollutants and temperature changes. If they survive and reproduce, it will confirm that the water quality and environmental balance are strong enough to support more complex interactions. There are also plans to introduce additional native plant species along the riverbanks. Certain shrubs and desert trees can help anchor soil, provide shade, and attract even more wildlife. Some of these plants grow very slowly, meaning the benefits will unfold over several years. But once they establish themselves, they play a crucial role in long-term ecological resilience. Trees create canopy cover that reduces surface temperatures. Shrubs slow wind movement. Root systems store moisture much deeper than grasses. These changes will further reinforce the microclimate emerging around the river. The project's long-term vision goes beyond ecology. It aims to blend environmental restoration with community development. There are discussions about building walking paths, educational centers, and research stations near the river. These additions would make the area a hub for environmental tourism and scientific study. Schools could incorporate regular field visits. Universities could host training programs in ecological engineering. Local businesses could benefit from increased foot traffic. The river could influence both nature and the economy. Even as the project grows, researchers remain cautious. Desert ecosystems are fragile, and a single disturbance can ripple through the entire system. A pump malfunction, a prolonged heat wave, or an unexpected pollutant could disrupt years of progress. That is why every decision is taken slowly and backed by detailed research. The early success is encouraging, but the long-term survival of the river depends on consistent monitoring and responsible management. Despite these challenges, there is an optimism surrounding the project that didn't exist before. For many years, conversations about climate change in the Middle East focused on scarcity, conflict, and decline. This river introduces a different narrative, one where innovation, resilience, and adaptation shape the future. One where countries facing severe water challenges can imagine restoration instead of retreat. Israel's experiment shows that drought-stricken regions don't have to watch their landscapes deteriorate. They can take action and rebuild what was once lost. This shift in thinking has broader geopolitical implications. As neighboring countries explore their own ecological restoration efforts, shared knowledge can lead to cooperation rather than competition. Water scarcity has historically been a source of tension in the Middle East, but shared strategies for managing scarcity could open new conversations about collaboration. Restored ecosystems near borders could provide cooling effects, reduce dust storms, and support biodiversity across regions. The benefits don't stop at political lines. By the time the river reaches full ecological maturity, the desert around it may look entirely different. Birds nesting along the banks, insects thriving in shallow waters, trees casting shade, and fish populating the deeper pools. What began as a controlled experiment will have grown into a self-sustaining system. And the most remarkable part is that the foundation of this entire transformation was wastewater that would have otherwise been discarded. Instead, it was turned into a resource capable of reviving an entire landscape. As we reach the end of this story, it's clear that this project is more than a scientific milestone. It's a demonstration of what becomes possible when a country refuses to accept environmental limitations as permanent. Israel didn't wait for rainfall to return. It didn't rely on hope or temporary fixes. It built a solution that blended engineering with ecology, turning a barren region into a living example of climate adaptation. The release of 1 million fish was not a symbolic act. It was the moment the river transitioned from an engineered channel into a living ecosystem. The early reproduction confirmed that the environment was strong enough to support life. The return of birds, the spread of vegetation, and the steady creation of a microclimate have all reinforced one message: nature can rebound when given the right conditions. If this story opened your eyes to what's possible in the world of environmental restoration, don't forget to like the video, share it with someone curious about climate innovation, and subscribe for more documentaries that explore how engineering and nature reshape our world.